Okay, let's see here. At everyone. Oh, look at that, all these people here all at once. Okay, let me just get some links ready for us. We're going to take a look at a few important web pages. I just posted them in the Discord, and then we'll sort of talk about what's going on there. And I also want to share with you some new homework that you can work on. So just give me 1 second to get all that ready for you, and then we'll start talking. I should put my earphones in too, in case anyone is trying to talk to me. Okay. Oh no. Oh, okay. That's fine. I'm sorry that that your internet broke. It's not a good time for that. My mic sounds fuzzy, or my. Mine does or Maya's does? Okay, let me, okay, let's see. How do I adjust that? No. Oh, is that better? Oh, no, that's awful. Cause, oh, yeah, that's really too bad. Cause I guess cause I'm using my, yeah, I have a sticky tab, like something like this. I have it covering my webcam when I'm not using it, and I guess I accidentally, like when I took it off, I put it on top of the microphone. But that sucks because that's been the case all day, so no one pointed that out in my morning classes. I hope they were able to hear me okay. Anyways, so yeah, we'll get started now. So I posted a couple links in here. Has anyone had a chance to take a look at these, or if has anyone stumbled across these links already? It's just information about the exam and the fact that they are going to be doing some review classes, which I think is awesome. So they have their own YouTube channel. So I guess this is their channel here. Yeah, look at this. They've got hey, look at that. They're doing a live video right now. Hey, just like me. It's Calc AB, but I mean it's still relevant to what we're doing. So wow, look at that. It looks like they're doing something just like what we're doing. So this is pretty cool. And hey, we should know what that is, right? That's the logistic equation, right? The logistic differential equation. So that's pretty cool. Anyway, yeah, so that's one of the links, and they have a whole schedule. So it looks like on the different live streams they have different schedules. So I guess right now is like what Eastern time is an hour after us, so it's like 2 o'clock or something. Yeah, so that makes sense. That was their live stream 3. So that's their calculus AB. So yeah, I'd highly recommend watching some of their videos. If they're live streaming it, my guess is that it'll probably be archived when they're done. So yeah, I would highly recommend checking out this link if you can. And there yeah, there's a few other links. So I just want to make sure that everyone has these links. So this one is just regarding what the exams are going to look like. So take a look through this. And if you have any questions, let me know. I'm not going to just sit here and read it to you. You guys obviously can take a look at this yourself. Yeah, that's what. Oops, I don't want to do that. That's what I wanted to show you first. Next up, okay, no. Here we go. Okay, so yeah, I want. Oops, can you guys still see the stream? No. Oh, okay. I hit escape by accident. Now can you see it? No? Okay. Shoot. Okay. Hold on a sec. How's that? let's try this. Come on. It looks all weird. Okay, let me try again. Sorry, guys. You hit one button wrong. The whole thing falls apart. Why does it look so weird all of a sudden? OBS Studio. Or OBS. Okay, let me see if I can figure this out. Try not to spend too much time kind of, you know, getting this to work. Okay, go live. Oh, I think that's better. You guys see that now? Can you see that? It's like a letterbox, like black bars. So frustrating. Oh, brother. Okay, hold on a second. Okay, I'm just gonna close this. This is gonna stop the YouTube stream. I don't know if anyone is actually, I think that people are watching the YouTube stream after the fact, but I don't think anyone is watching it live. So I just don't want to cut anyone off if they're in the middle of watching it. Just give me 1 second. Oh, it looks like one of my grade 7 students dropped by to say hi. Hello. Okay, so I'm gonna just end this then, and okay. Sorry to waste everyone's time here. This is kind of embarrassing. Okay, what am I gonna do? Okay, so YouTube is back up, and let's see if we can get this to work now. Okay, full screen, and get Discord. Come on. Okay, I think that's got to work. It looks like it's working from my end. Is that working? Okay, beautiful. Okay. Okay, so that now that that's out of the way, okay, so I'm gonna post some homework, and I'd like you to focus on that for now, and so we'll kind of take a break from the textbook. I wanna also show you, and I think Ron brought this up yesterday, just about how to use a change of variable to make some of our derivatives like much easier to solve. So I want to go over that problem that we had last time. So I think what it was like 600 over what was it? 1 plus 4 times e to the negative 0.02t, right? And we were asked to take the second order derivative of this. Well, we were asked to take the derivative, and then we were asked to take the second order derivative. And I wanted to address it yesterday, but I wasn't quite sure exactly the tools that we needed. So I I was a little hesitant to jump right into it, but I spent a little bit of time last night kind of mulling it over, and I think I know how to explain it. The idea is that we're going to just sort of use the chain rule to make this easier to differentiate. So what we'll do is we'll say that this is y. So y is now a function of t. But if we, like the main source of issue is this kind of ugly beast right here. If this was just one variable, then it would be much easier to differentiate. So what we're going to do is we're going to say that u, so we'll let u equal 4 times e to the negative 0.02 times t. So when we do that, our question immediately becomes much easier to solve, but we do have to make sure that we take all the right precautions when we do that change of variable. So one thing that I am going to need to know at some point is what du by dt is equal to. So in other words, what's the derivative of u with respect to t, right? Or in other words, like d by dt of u. And that's going to be, well, 4 times negative 0.02, which is we are getting to that. We are getting to that. Just hold your horses. I'm just kind of getting some stuff out of the way here. So this is going to be negative 0.08 times e to the negative 0.02 t. Okay, so that's what du by dt is, right? Now what we were asked to do is find dy by dt, right? We wanted to differentiate this function y with respect to t. But now that we've changed the variable, we've got a different thing. So we've got, well, this is 600 over 1 plus u. So if we want to differentiate with respect to u, we have to use the chain rule. So the chain rule is going to give us something that looks like this. So dy by dt is equal to, well, dy by du. So basically the derivative of this with respect to u. And then we kind of use this sort of fractional derivative notation. So this is equal to du by dt, or sorry, so I have to multiply by du by dt. So basically thinking of it like the derivative of the inside. That's kind of often what we refer to when we're using the chain rule. So this is the derivative of the inside. Okay? And that's exactly what we just calculated right here. That's du by dt. So that's why I wanted to calculate that first. So dy by du, that's pretty straightforward to calculate. So this is going to be equal to 600 over d by dt of 600 over 1 plus u, which really isn't too bad. And then we're going to multiply all of that by negative 0.08 times e to the negative 0.02 t. So this is kind of like the only ugly part right here, and we already got rid of that. Like we already figured out what that part is. The rest is just a fairly straightforward derivative to calculate. So this is going to be 600 times, well, you can kind of think of this as being multiplied by 600, except it's got an exponent of negative 1. So we'll just have negative 1 times 1 plus u to the negative 2, all times this thing, which is negative 0.08 times e to the negative 0.02 t. And that's pretty much it. And we can clean it up a little bit. I think that we end up getting 48 just by multiplying this and this together. We get positive 48. And we're left with 1 plus u to the power of negative 2 times e to the negative 0.02 t. And that's, if we really want to, clean that up, that's going to be 48 e to the negative 0.02t all over 1 plus u squared. But we don't want u, right? So let's go like put it back into terms of t. So we've got 48 e to the negative 0.02t all over 1 plus, and I believe u was 4 times e to negative 0.02t, and that's all squared. So I would recommend, you know, looking this over, because when we're you know, solving logistic equations and differential equations, we may have to do some derivatives, and it's been a while since we did derivatives. I think yesterday, I think it was pretty clear that even I had some difficulty calculating some of these derivatives, because it's been a while. I mean, it's been a while for you. It had been like almost a decade for me since I took a derivative, but you know, it's been a few months since you've done any, like, you know, real derivatives that actually take some time to you know, actually calculate, and not just like one-liners, but questions that take, you know, maybe 7 or 8 lines. So I'd recommend. Sorry, go on. Like, oh, okay, sure. Yeah. So just on the side here, so dy by dt, that's really just a fancy way of saying d by dt of y. So it means take the derivative. So this is an operator, right? Take the derivative of y. And then this is saying, like, with respect to t. So take the derivative with respect to t of y. Well, y is this guy right here. Except we've already said that this is equal to u. So we've just replaced this by u. And I've made a little error here. This should just be that y is equal to 600 over 1 plus u. And then we would want to take the derivative with respect to t there, but we can't take the derivative of respect to t, right? We can only take the derivative with respect to u, because there is no t now. We've replaced t with u. So when I take the derivative of y with respect to t, like right here, I'm going to use the chain rule. So basically, I'm going to say, okay, well, I'll take the derivative with respect to u, but then I have to multiply the derivative of u with respect to t, right? That's what the chain rule is. So taking the derivative of y with respect to u, that's this portion right here. So this is y. So maybe I'll try to do a better job of color coding this. So this is y right here. So y is equal to 600 over 1 plus u. And that's what this is. So this is 600 over 1 plus u. And that's what y is. So I took d by du of y. And, oh geez, look at this. I made another little typo. I'm sorry, guys. This might be why you're having some issues. That should be d by du, right? Because we're taking the derivative of y with respect to u, right? So this is d by du of 600 over 1 plus u. And then what's left over is, you know, what we often refer to as the derivative of the inside, right? And maybe I should use a different color yet again. So this is the derivative of the inside. And that is what is I wrote right there, right? So that was one of the first things I calculated. So if we do a substitution, we're going to have to calculate what that substitution is, like what our u is, what the derivative of u is with respect to t, because we're going to have to multiply it out at some point. So does that answer your question? Okay. Okay, so yeah, so why don't I go and grab that worksheet that I wanted to post, and I'll put it on the website now. And so we're gonna sort of take a break from the textbook. I think we did our time yesterday. So let's see, we're on chapter 10, and okay, so I've got these questions here. I'm going to copy them, put them into our website. Chapter 10. There we go. Okay, so I'm going to post this on the website now. And that's what I would like us to work on instead of the textbook, because I think that these are actually better questions. Sure. Yeah. Okay, 10.2, number 15. What page is that? Yeah, okay. Yeah. Okay, well, what do you think a good choice for? So if you're not able to see this, I'll just describe what the integral is so you can follow along. It's on page 447 of our textbook, and it's question 15. So that is it's an improper integral. It's from negative infinity to positive infinity, and the integrand is x times e to the power of negative x squared dx. So yeah, let's attack this one. So I'm gonna quickly just graph this on Desmos just so we have some kind of idea what it looks like. So let me pull up Desmos. Okay, so this is x times, I mean, we don't really have to graph it. I just want to kind of give you an idea of what we're doing. My guess is that it's going to look like some kind of little bump. So we've got, what is it, x times e to the power of x, negative x squared. Negative x squared. Is this it here? Yeah. Okay, so it's kind of like a little bump. So it looks like this is an even function, right? So my guess is that the derivative is going to be 0 because the little bump on the left is in the negatives and the bump on the right is in the positives. They look like they're about the same size. So yeah, my guess is that this integral is going to be 0. A good place to split this integral up, and this is true of like most improper integrals where you have the endpoints being positive and negative infinity, is cut it right down the middle if you can consider 0 being the middle, but I think you know what I mean. Just cut it down at 0. So let's split this up into two integrals. So let's say that this is going to be from negative infinity to 0 of x times e to the negative x squared dx plus the integral from 0 to positive infinity of x times e to the negative x squared dx. Okay, and if you wanted to, like you could just say, look, this is going to be an even function. You could throw some positives and negatives in there, and not an even function, an odd function. This is an odd function. So basically saying that if you put do you guys know the difference between even and odd functions? Okay, okay, you know what? How about 2 weeks? Okay, so you've heard of it. I'm gonna talk about even and odd functions after this. I think let's not get too distracted. I have a tendency, I don't know if you've noticed, but I have a tendency to get distracted. So let's solve this, and then when we're finished this, then we'll talk about even and odd functions, okay? Okay, so this, let's just focus on solving this one first. So I'll just write it on the side here. I've got negative infinity to 0, x times e to the negative x squared dx, and that's going to be equal to the limit as t approaches negative infinity of t to 0 of x times e to the negative x squared dx. Okay, so this is going to be, so I think we should do some kind of substitution. I think that's probably where we want to go with this. So I'll just write the limit again as t goes to negative infinity of t to 0, and then I'm going to say on the side here, let u equal, let's call it negative x squared. So du is going to be negative 2x dx. And I see an x dx, so I'm going to say that x dx is equal to negative 1/2 du, like that. Are we okay with that? Okay, why are you guys so quiet? There's like, how many people are in the chat right now? We've got like almost 10 people in the chat. No one's saying anything. You gotta tell me some. You're all muted. Oh, you're listening to music? No one's on Spotify. Okay, geez. You gotta speak up. Okay, so I've got e to the u du, right? Oh, and then that's gonna be, I'm gonna have a negative 1/2 out here, because of this. So let me just write that a little bit more nicely so it's a little more legible. Okay, so I've got negative 1/2 out here. Okay, and this should be fairly easy to integrate, right? This is going to be, and these are limits. That's like x equals t, and this is x equals 0, right? So I'll bring it back in terms of x in just a second. So let's see here. This is equal to the limit as t goes to negative infinity of negative 1/2 of e to the u, and we're going from x equals 0, x equals t, and let's bring that back to negative x squared. So this is the limit as t goes to negative infinity, like this, negative 1/2, yada yada yada, e to the negative x squared from t to 0. Okay, so this I'm gonna get negative 1/2 of, well, when x is equal to 0, I've got that e to the negative 0 is, that's just 1, and then when e to the, so the limit as t approaches negative infinity of e to the negative x squared, or I guess that's t squared rather. Well, let's think of what happens. So I'm going to have a negative times a negative, which is a positive. So this part is going to be positive, but then I've got another negative because this is a minus sign. So so this is going to be e to the power of negative infinity, which tends to 0. So this is equal to negative 1/2. Okay? Is that okay? Okay, good. Okay, so we're going to get a really similar result with this other integral, right? So really what we did here was, I don't know how to use Desmos very well, but really like I calculated like the area under this left portion of the curve, like from negative infinity to 0. So this kind of little bump on the bottom left. Just by looking at it, I mean, I'm hoping that you can see, I'm guessing that these are going to be exactly the opposite, right? So the one on the left was negative because it's underneath the x-axis. The one on the right is probably going to be positive, and it's probably going to have exactly the same area. And, well, it turns out that it is going to be, and you'll see that in just a second. So we calculated this one right here. Let's calculate this one now. So the thing is, it's going to have exactly the same antiderivative. The only thing that's different are the endpoints of the integral. So we're going to have just a slightly different limit. So let's calculate it. So I'm going from 0 to infinity of x times e to the negative x squared dx. And that is going to be the limit as t approaches positive infinity this time of, what did we end up getting? Negative 1/2 of e to the negative x squared. And this time I'm going from 0 to t. And by the same argument, except this time it's just going to be our signs are going to be different. So this is going to be, well, this time I'm going to start, or don't forget the negative 1/2. This time I'm going to start at t. So when t goes to infinity, I get 0, right? Because e to the negative infinity is 0. And then I'm going to subtract e to the 0, which is 1. So this is going to be negative 1/2 times negative 1, which is positive 1/2. So the two together, so in other words, so the negative infinity to positive infinity of x times e to the negative x squared dx is going to be negative 1/2 plus 1/2, which is 0, right? So that one is 0, just like we kind of conjectured, right? This looks like it's going to be 0 because both of these are going to be the same. So let's quickly talk about odd and even functions. So odd and even functions. Okay. So an odd function have the form f of negative x is equal to negative f of x. That's what an odd function is. So it's a function that looks kind of like this. So let's just look at what happens on the right here. So let's say I've got something like this. Well, we're going to have the exact opposite thing happening on the other side. It's going to look something like this. Okay, so if you ever have to take the integral of an odd function where the endpoints are opposite numbers of each other, like this, like maybe this is negative a, this is positive a, well, we know that this area is going to be exactly the same as this area, except it's going to be under the curve, whereas on the right it's over the curve, so they cancel out. And that's really what we just had. This is an odd function. X times e to the negative x squared is odd because, well, try replacing x with negative x and see what happens. Well, if I have negative x times e to the negative x squared, well, negative x squared is the same thing as positive x squared because we're just going to square that negative. So this is equal to negative x times e to the negative x squared, which is the negative of our original function. So when you replace x with negative x, if that factor of that minus sign comes out, then that means that your function is odd. So an even function is a little bit different. Actually, it's quite different. basically f of negative x is equal to f of x, that there is no difference, and that would look something like this. So you would have so no matter what happens over here, it's going to look exactly the same except mirror imaged on the other end. So that's useful for integrating, because if you're taking, again, an integral with opposite endpoints, like negative a to positive a, well then all you have to do is just calculate half of it and then double it, right? Because these are going to be the same area, right? So so throwing in some facts about odd and even functions can really save you some time. Really, like, all I had to do here is, if I noticed that this is an odd function and I'm going from negative infinity to positive infinity, well, that just immediately, just by knowing that, immediately I know that this integral is equal to 0. You don't even have to really calculate anything. Does that make any sense? Like, or am I just making things more confusing? Or, okay, anyone other than Nick? Are you guys all asleep? Can you type something? Okay. Yeah, we could try that if we want. Honestly, I don't know what that would look like, but let's have some fun. Let's see if we can try to do that. Okay. Yeah, I think so. Correct me if I'm wrong, Maya, but I think that you're wanting to say something like this. So the integral from negative infinity to positive infinity of x times, let's just do the same question again, dx. So I think what you're saying is that you could have something like this, the limit as, let's say, let's use the letters a and b. So that a goes to negative infinity. For some reason my infinities are off center. There we go. And of the limit as b goes to positive infinity, of the integral that goes from a to b of x times e to the negative x squared dx. My only concern, so this ends up being true, but my only concern is that these limits are non-commutative. So it's not immediately clear which limit you should be writing first. So so when you have more than one limit, you do have to be very cognizant of which limit you take first. So I'm gonna go ahead and say don't do this for now. If you want to learn more about, I think they're called iterative limits. So if you want to learn more about that, there's it comes up in calculus again. But honestly, it's been a while, and I forget exactly what the conditions are that when you can take that. So I would recommend just looking it up and doing kind of a your own sort of self-study. One thing that we could try doing, though, is we could do something like this. We could say that this is equal to the limit as a goes to positive infinity. So we'll take one limit, but then we'll go from negative a to positive a, right? So that's still just taking, that's still leaving it into just one limit. We're still just taking one limit. We're not splitting it up into two integrals. And then what do you mean the same infinity? We're taking a limit as a approaches infinity. Yeah, it doesn't really matter, and in any case it's the same a, so they would be increasing at the same rate, right? It's the same variable. So when we say like take the limit as a approaches infinity, really all that's saying is it's saying find, like, for any number, like the reader of the question can take any number that they want, let's call it capital N, and a is going to be bigger than that capital N. That's all the limit means, is that a is bigger than any number that you could imagine. So the reader could say, okay, well, if n is bigger than, if n is equal to like 10 to the power of 10 to the power of 10 to the power of 10, then a is going to be bigger than it. And that's all the limit means. Yeah, thank you. Yeah, n is going to be smaller than a. So that's really all a limit means when we take a limit to infinity. But yeah. So I think that would, I don't think we'd be breaking any rules there, because that's really what it is equal to. But it may, like, you might be surprised that the algebra does actually kind of blow up. I mean, I think in this case it's fine because it's in an odd function, so everything's just going to sort of fall into place. So in this case, we'll have the limit as a approaches infinity of what did we say the antiderivative was? Negative 1/2 times e to the negative x squared. And now we're going from negative a to a. So this is going to be the limit as a approaches infinity of negative 1/2 of e to the negative a squared minus e to the negative a squared again. So you can see that these just doesn't matter what they're equal to. It's just 0. So this is equal to 0. So in that case, it works out pretty nicely. But I would still recommend just splitting that integral into two pieces and integrating them separately. But if you really want to just combine it into one limit, you could try that out. See how that works. Okay, I think, did I post? Oh, I was just about to post that logistic questions. Okay, no, copy link. Okay, just give me 1 second here. Okay, so I'm gonna post this this worksheet on the website. Here it is, and I'll post it right at the top here. So it's logistic equations. I'll put the date on it. So March 25th, logistic equations. So I've gone ahead and published that now. So it should be available for you any second now. These are just practice. So I guess we have about 10 minutes before my next class starts. So before a whole lot of time goes by, I just want to share with you Crowdmark. So Crowdmark is going to be the platform that I'm going to use for assessment, so like grades and that kind of thing. So what I'm going to do is I'm going to just give you like the same test that I was planning on giving you, except it'll be on Crowdmark. So it'll be like a test except an assignment, if that makes sense. So you'll get a little bit longer to work on it. So I'll probably give you like a full day to work on it. And then you'll submit your questions by taking a photograph of your work and then submitting it. So we'll try to use that hopefully as soon as possible. I'm thinking maybe I can give that to you by the end of the week, but we'll talk about it. So I guess we only have 2 days left of this week, so tomorrow and Friday. But we'll talk about it tomorrow, and we'll come up with a plan. I am a little hesitant to give you work over the break, but again, that's something that we can talk about. Maybe that's something that you want. I don't know. Usually when it comes to taking a break, I like to give my students a break. But if you want to use this time to catch up, I'm certainly happy to give you some material. But as far as like graded things go, I think I really would like you to just work on it, when we're actually having school, and then when you have the break. I don't want to be like administering online tests and stuff like that during March break. So yeah, tomorrow we'll talk a little bit about Crowdmark. I think we'll talk about it tomorrow. I mean, it would be really nice if we could be done chapter 10 before the break. So like we've done all the lessons. We've had some time to work. So what I'd like you to do is take a look at the assignment that I posted. I'm kind of assuming that logistic equations are probably going to be the cause of the most trouble. So make sure you spend enough time with logistic equations so that tomorrow you can come prepared with questions and things like that. Yeah, I guess that's really all I wanted to say is, so make sure that you have enough time to work on the logistic equations problems. I think, let me see here. I don't know if I have an answer key. I do have an answer key. Your internet's fixed? All right, I'm glad to hear that. Do you have to unplug it and plug it back in again? Oh, nice. Okay, so yeah, I'm gonna sign out now. I'm gonna post the solutions as well, so you can. Sorry, go on. That's another thing we're gonna talk about tomorrow, is how we're gonna sort of get around the fact that I can't really monitor everything that you do. I think it'll mostly just boil down to an honor system, and I mean, and if that means that maybe like I lower the amount that these tests are worth, just to sort of encourage you to really just do your best and be honest about it, and just bear in mind that as far as I understand, the AP Calc, like the College Board exam, like they're going to be taking cheating quite seriously, so they'll probably have some stuff with webcam. So it's probably just a good idea just to figure out how this works honestly, and then if you have difficulties, then I'll give you feedback, and it's probably going to go a lot better for you if you just be honest about it. So it'll probably just be an honor code thing. I really don't want to have to monitor webcams and things like that. So let's talk about that tomorrow, though. In the meantime, make sure that you've had enough time to try these logistic equations or logistic function questions, and then we'll take a look at them tomorrow. Okay. Okay. Mm-hmm. Mm-hmm. Yeah, but you have to find out what K is and what L is and what Y naught is, right? Yeah. Find the unknowns and then put together your logistic equation, right? So you could have the logistic differential equation, right, which is a little more straightforward, or you can have your logistic just actual equation, right? The one where you've solved the differential equation. So, yeah, I think they're already up. I'll put the solutions up there too. I just copied them to the Google Drive. Yep. Yeah, they're up there. Like I just put them up like 10 seconds ago. And I'll put the solutions up there now. Okay. Yeah, under AP Calc, it's, yeah. Oh, I guess I'll put it over on top of March 20th because we're way past that. So I'll put in a new section. Oh, okay, so I've got the March 23rd live stream. I guess I haven't really been updating the AP Calc section of my website super often. So let me fix that. So I'll put it right at the top, and then it'll be super easy to find. Okay, and then this is going to be a different color. Let's make it gray. Delete this. So yeah, it should be, come on. Okay. And I'll post the videos that I've been recording on the same section too. So okay, any other questions before I go? Okay, you guys holding up okay? Are you being driven insane by having to stay inside this whole time? Yeah, it looks beautiful outside. Yeah. I heard that in New York City, it's like basically illegal to go outside unless you have a dog. So I heard that what people are doing is they're walking their dogs to their friend's house and then leaving the dog there so that the dog can go for another walk, and then everyone gets to like share the dog walking experience. Kind of strange. Okay, I'm gonna go. Don't hesitate to reach out on like an email or whatever, and I will talk to you tomorrow. Okay, bye bye.